So word line 1 is on. That means let's call this transistor N. My transistor N is on. Now let's see what's happening with transistor N. Transistor N has one foot which is connected to bit upper, which is nothing but VDD by 2. It is on because word line 1 is equal to 1, and the other foot is connected to a capacitor which is charged to VDD. So we know that one terminal is at VDD, another terminal is at VDD by 2, and word line 1 is 1. That means this is a closed circuit. Charge sharing will take place, due to which what will happen is my bit upper will go up by delta V, whereas my C cell voltage will go down such that both of them achieve the same voltage. We all agree this, and we have seen this in the previous clips. So bit upper goes to VDD by 2 plus delta V. Remember, at the same time, my bit lower, it's still at VDD by 2, because for the simple reason, none of this NMOS transistors are on, and bit low stays to what it is. And now if you see properly, this sense amplifier NMOS is, let's say NSA, this is just conventions, and NSB, sense amplifier A, and sense amplifier B NMOSes. This is connected to bit, this is connected to bit upper, this is connected to bit lower. So what's going to happen is, this gets a value VDD by 2 plus delta V, whereas this gets a value VDD by 2. And now I make my read enable signal equal to 1 because I want to start reading. That means when I make my read enable signal equal to 1, this NSA and NSB transistors will turn on. So would be this NMOS. So I will have a current towards ground because this is nothing but a closed switch. When NSA and NSB is on, it passes whatever is there at its input. So X will have a value VDD by 2 plus delta V, whereas Y would have a value VDD by 2. And this X and Y are given to this sense amplifier, correct? So they are nothing but cross-coupled inverters, which is like this. This is my inverter 1. This is my inverter 2. This is connected towards ground because it's a closed transistor, and this is VDD. So I'm straight away making X is VDD by 2 plus delta V. X is going as an input here. So let's say VDD by 2 is 0.9 plus delta V as 100 millivolts. Let's say it's approximately 1 volt, and this is approximately 0.9 volts. So X is 1 volt. This is 0.9 volts. Just an assumption that VDD by 2 is 0.9 because Y is 0.9. Now we have seen the working. Both are technically greater than 0.89. That means both would be interpreted as a logic 1 at this point of time. That means this NMOS and this NMOS, both transistors are on. And because both these transistors are on, they both will try to pull their respective outputs towards ground. Who will be able to pull down first is the one who will have a greater gate voltage, because ID is proportional to VGS. So whoever has greater gate voltage will have a greater ID, will be able to pull its output node towards 1 first. So here we see that the 1 volt is going to this transistor, so this transistor will go towards 0 first. So let's say node Y will go towards 0 first, or in simple words will go to a value which can be interpreted as a logic 0 first. And once this happens, we know that Y is an input to this block, so this inverter will now get a 0 at its input, which will turn on this PMOS and will produce X to VDD. So what we did was, X was VDD by 2 plus delta V and Y was VDD by 2. So I made that VDD by 2 plus delta V to be equal to VDD and Y equal to 0. Now what we have to do is, if we put our output probes here on bit upper line, or you can easily say that on the X line and on the Y line, correct? You will easily find out that X is VDD, which means bit upper had a 1 written somewhere, and there is bit lower going to 0. That clearly means that there's nothing which has happened, because it was nothing but VDD by 2 which went off to 0, and VDD by 2 plus delta V went on to VDD. So here if you see, your bit line has gone to 0 lower and bit line upper has gone to VDD. Now if you check the output of your row decoder, you will come to know that word line 1 was high, which means the reading was happening on the upper 64 cells, correct? And that also, when the upper bit has turned to VDD, that means you have read a 1. And where exactly have you read a 1? It's nothing but it will depend on the word line 1. So it will tell you that it's in the first cell that you have read a 1. At the same time, this is going to 0. However, all these transistors are off, so it's not going to change anything into your circuit.